Assalamu alaikum dear students. Today we are going to define what's group. We try to understand group. Before discussing the group, please understand what's binary operation. Watch my previous lecture on binary operation. Let G be a non-empty set, that is G is non-empty set, and steric be a binary operation. What is binary operation? Please watch my previous video. Defined on G, then G is a group under steric if it satisfies the following axioms or properties called group axioms or properties of group. First, G is closed under steric, and how steric is closed? That is, for all A, B belongs to G implies A steric B, it also belongs to G. This is closure property. Second, steric is associative BO. BO stands for a binary operation, but steric associative binary operation on G, that is, for all A, B, C belongs to G implies A steric B steric C is equal to A steric B steric C. This is associative. Number third, there exists an identity element E in G under steric, that is, for all A belongs to G, A steric E equal to E steric A. E is the identity element, and E may be 0 if steric is addition, and E is 1 if steric is multiplication. And fourth property, there exists inverse of each element in G under steric, that is, for all A belongs to G, there exists A dash or sometimes A power minus 1, A inverse. It also belongs to G such that A steric A inverse or A dash equal to E equal to A dash steric A. If these four properties are defined on non-empty set G under binary operation steric may be addition, subtraction, multiplication, division, methods of multiplication, vector multiplication, addition, or any operation, then we say G is a group under steric, or G comma steric is a group if these four properties are satisfied. And next, fifth property, if steric is a commutative binary operation on G, that is, for all A, B belongs to G implies A steric B is equal to B steric A, then we say G and steric is an abelian group. Abelian was a mathematician and he discovered this group. So in his memory we say G is an abelian group if commutative property holds in G under steric. Please remember these properties and have a screenshot. Now I would like to explain the group with the help of an example. To prove Z, we know Z 0 plus minus 1 plus minus 2 plus minus 3 plus minus 4 and so on. It is the set of integers. We prove first 4 properties. Let's say 2 and 3 belongs to Z, then 2 plus 3 equal to 5, it belongs to Z, mean Z is closed under addition. Here, if any set contains 0, then it will be the group, may or may not group according to addition, because additive identity is 0. It will never be a group under multiplication, because 0 has no multiplicative inverse. Again, the first property is proved. Number 2, addition is associative on Z, obviously. Second property is proved. Third one, 0 belongs to Z. 0 is the additive identity, and for all A belongs to Z, A plus 0 equal to 0 plus A, mean identity exists. Again, fourth, inverse of each element in Z also exists. For example, 2, its inverse is minus 2, and 2 plus minus 2 equal to 0 equal to minus 2 plus 2. Similarly, inverse of 3 is minus 3, 4 minus 4, and minus 5, its inverse is plus 5. You can say for all A belongs to Z, its inverse A dash or minus A, because under addition its inverse is minus A, belongs to Z, mean inverse exists. Fourth property is proved. So Z is group under addition. Obviously, for all A, B belongs to Z, A plus B is equal to B plus A, mean addition is commutative. Addition is commutative. So we can say Z is an abelian group under addition, that is Z and plus is an abelian group. Now again, from the definition of group, we explain some further definitions or definitions related to group. If G is a non-empty set and steric is closed by the operation such that steric is closed, associative law does not exist, only closure law holds in G, then we say G and steric or G comma steric is a groupoid. It is a groupoid. And if in a groupoid mean only closure law holds. If two properties hold, G is closed and steric is associative boundary operation on G, then we say G comma steric is a semigroup. If two properties hold, closure and associative, then G is a semigroup. And if three properties hold, closure, associative and identity exists in a G under steric, then G and steric is a monoid. Or you can say in a semigroup identity exists, then it is a monoid. And if the fourth property hold are in a monoid, inverse of each element hold, then it is a group. And finally, if steric is commutative binary operation, then it is an abelian group. So these are the group related definitions. I think you can understand. So please like, subscribe and share to your friends. Thank you.